In this part of the lecture, I wanted to remind you that we are in the course of organic reduction and in the lesson about soil fertility management, as you see in the slide. Another important property of the soil is the soil pH. The pH is the concentration of the active hydrogen ions in the soil solution. Why it is important? Because it is an indication of the acidity or alkalinity of the soil, and this is also known as soil reaction. The pH values range from 0 to 14. The values below 7 are acidic, or the soil reaction is acidic reaction. And the values above 7 shows an soil pH that is alkaline. A pH value of 7 is considered neutral. In this case, the concentration of hydrogen and hydroxyl are equal, both at a concentration that is shown here. A pH of 4, in fact, is 10 times more acidic than a pH of 5. This means that even we have a change from one unit, from one level of pH reaction to another. In fact, the difference in the air effect they produce is huge. The most important effect of pH in the soil is on ion solubility, which in turn affect especially the plant nutrition, plant growth, and microbial activity. A pH that has the values between 5.5 to 7 is considered optimal. And in this range, when the pH has the values 6 to 6.8, it is ideal for most of the crops because it coincides with optimum solubility of the most important plant nutrients. Some minor elements like iron and most of the heavy metals are most soluble at lower pH. This means at acidic pH. Looking to the values of pH from this point of view and from this effect they have in the metals and heavy metals, this means that pH management is important in controlling movement of heavy metals in the soil, and if the metals are in a soluble situation, then we have the possibility of contamination of groundwater and for sure the soil. In acid soils, hydrogen and aluminium are the dominant exchangeable cations. The aluminium is soluble under acid conditions, and its reactivity with water produces hydrogen ions. From the other side, calcium and magnesium are basic cations. As their amounts increase, the relative amount of acidic cations will decrease. Magnesium and calcium cations are important for soil structure. Just to remind you, when I explained the soil structure, and we learned that particles of the soil bind together and create pads, and they together again create these pores and channels in the soil. And in this case, I just to remind you that magnesium and calcium are important to create this structure together with organic matter. In this slide, you have an image that is explaining what I was saying before. As you see, we have here explaining how the nutrients and metals change their behavior depend on the soil reaction. So you see this for acidic environment, neutral and alkaline. As you see in the middle of the image, where the pH is neutral, we have most of the nutrients soluble and can be taken by plants. Then when we go in two different directions, to acidic or to alkaline environment, you have changes, and nutrients, some of nutrients then become not soluble and cannot be taken by the plants. But then you have, especially to acidic, you see, for example, that most of the heavy metals become soluble. Factors that affect soil pH include parent material or rock, mother rock or bedrock, vegetation, so plants or type of the plants or species of the plants, and climate. Let's speak about parent material or parent rock. Some rocks and sediments produce soils that are more acidic than others. For example, quartz-rich sandstone is acidic. In contrary, the limestone or the soils that have the origin from the limestone or have high concentration of limestone, they are alkaline.